Okay, so welcome everyone to the course Industrial Robotics and Automation. In today's lecture, we will be studying about fluid power or to basically evaluate the role of fluid power in industrial automation. Okay, so fluid power, what is it? It is actually a technology that deals with the generation, control and transmission of power using pressurized fluids. Okay, so it is not only your generation, or it is not only the control, it has to be all three. Okay, right from where you generate the power, all the technology requiring to generate the power, then again the transmission, that is the end where it is going. Between that, they will also be coming as the control elements. So how do you control those pressurized fluids? So all three: the generation, control and the transmission of power using the pressurized fluid. So when you talk about fluid, it is actually, when it is liquid, you name it as hydraulic, and when it is gas, okay, it is pneumatic. Or basically, if you can categorize in the other way, any incompressible fluid if you are using, okay, then that forms basically a hydraulic. Specifically, we use oil in the hydraulic portion, and if it is compressible, okay, generally your normal atmospheric air, that is the gas, then you claim it to be your pneumatic. Okay, so now let us again try to evaluate the fluid power or its role of fluid power in automation through a few examples that we'll see. Okay, so the first one, we are going to discuss about two tasks that we are going to perform, and then seeing both these tasks, okay, you will be able to better judge, or you will be able to evaluate or to predict, okay, in which case we would be using which type of power. So the first task is what? A linear movement of 150 mm of weight 20 kg. Okay, so you have a 20 kg weight. What is your requirement? A linear movement of 150 mm, and then again the most important thing is that the repeatability of 100 microns. That means the accuracy required here, okay, is very high. So immediately if you see this task, what comes to your mind? If you go, or if you just brush through your previous lectures, okay, in this course that you have studied, what should automatically come to your mind is your motors, right? So because all this accuracy, but again motors is what? Circular movement or your rotary movement. So how are you going to convert this rotary movement to your linear movement? Of course, yes, you can have your slides mechanism, okay, blood screw and slides and all the different types of mechanisms to convert your linear motion, your circular motion to your linear motion. Okay, and only then you can have a accuracy or a repeatability of around 100 microns. See, 20 kg load is not so high. Okay, it's if you put it in the category, it is generally a low weight that you have to do. Then again, the movement is also 150 mm, and then the only catch here is your very high accuracy or repeatability, if you can say, in this case. Okay, so what you will do, you will basically use a motors. Now even if you go to motors, you have studied a variety of motors, okay, right from your DC motors to your stepper, and then your AC motors and all these things, servo and without servo. Okay, so again you will have to judge yourself, or you will have to evaluate as to which motors will do the task. Again, as I told you, even if you have to calculate just a small value of, say, 20 divided by 6, you can again use your calculators or your again your mobile phones, and then your PC. You can also go up to a high end of supercomputing and all those things. So what you actually try to do is see what type of task is there, and then give your best or the cheapest alternative to doing that task. Okay, so again if you just go to use servo motors, then again the cost will become very high. And if you have to ensure that, okay, within it is in this limit, okay, the feedback mechanism is, you require a feedback mechanism, then you'll be going for servo motors, or else it will be sufficient to do it with your stepper motors, right? So this can be one way of doing this task. Now just look at the other task that is there on the bottommost of your screen. So it says what? Lifting a weight of 500 kg up to a height of 500 mm or 50 centimeters. Now see, when this task, if you see, what immediately comes into your mind? Okay, so the height that this weight is to be lifted is 50 centimeters. And again, the weight is, if I put it into a category, I will put it into a higher amount of weight that is there, because 500 kg is a substantial load to be lifted. Okay, so the moment you see this thing, immediately what comes or what should come into your mind is that, okay, since the travel distance is not so much, we can go for a fluid power, right? Because see, all your if you see the earth movers or your JCBs and the other caterpillar types of machines that they are going to, they are all again based on a hydraulic system. They are doing a very heavy lifting task and all those things. So whenever the weight is on a higher side, okay, then you go for a hydraulic system. Okay, and if the weight is on a lower side and if you do not need a much more accuracy, then again you can go for a pneumatic system for this. All those possibilities, okay, we are going to just explore more and more in the upcoming slides. So why fluid power? Okay, the question arises, why is it fluid power? So if you see most of the industrial processes, okay, basically if you can just imagine your manufacturing processes. Okay, so most of them, what, either you have a movement from one location to the other. Second, you require a force either to just hold a load against something, okay, or to press a workpiece against something before, say, to be specific, if I just give you an example, you have a drilling operation, you require your workpiece to be clamped. Okay, so there can be a certain force that is just pressing the workpiece before the drilling operation is going to do. And then again, you have your different forging and all those pressing applications where you require to shape or you compress a product to a desired configuration. Okay, so when all these basic industrial processes that are there, that comes to your mind, what is that? These all activities are actually performed by your prime movers. Prime movers are the basic energy source that convert from one form of energy to the others. Okay, so in most of the locations, if you see, majority of these all these applications, your prime movers are generally your electrical devices. For example, you can move one to the other by using motors fitted to a conveyor belt. Then again, you can apply a load, okay, with the help of motors, and then you can also shape and compress by again the same mechanism. So if it is a rotary motion, again it can be provided by simple motors. Okay, and if it is a linear motion, then again you can have a screw jack arrangements or your rack and pinion. Okay, and then you can have your linear slides. Okay, ball screw mechanisms and all those things. So they can be done. These all motions can be done by electrical equipment. Although these are rotary in nature, but then again they can be converted also to your linear motions. So, but then again, the electrical devices are always, okay, not the only means of providing power to the prime movers. Okay, they are always not the only means of prime movers. When you talk about a low cost automation, okay, low cost substitute for that, okay, where your accuracy and where all those your repeatability and all those works are not required up to a certain levels. Okay, say for example the first example that you see where the 150 micron repeatability, if I just remove from the first problem, then again that I can do it using a pneumatic also. Okay, just using a compressed power source. So again, so that time electrical devices are not always an option of a prime movers. What do you have? You also have your enclosed fluids. Okay, both liquids or gases. They can be used to convey the energy from one location to the other, or they can also be used to produce linear or rotary motion, or also to apply the forces, which are generally the prime requirement of a prime mover. So all those things can also be achieved by a enclosed fluids. So basically, if these fluids are based on liquid, then it is known as your hydraulic, and if these fluids are based on your gases, or if they employ gas to do the necessary tasks, then we call those systems as your pneumatic systems. So now let us again take one example, okay, a similar example that we have seen, and then we'll compare all these three modes of, for example, prime movers. For example, we'll be doing that task using a electrical system, and then we will be doing that same task using a hydraulic and then a pneumatic system, and we will see what are the advantages and disadvantages of these systems one over the others. Okay, so again, let us take a same example that can be flashed at the right side of your screen. So you have a weight, and that weight is to be lifted to a height of 500 mm. Okay, these tasks are very common in the manufacturing industries. Okay, not even even if you go to other industries, so lifting of load is very common. Okay, you can also nowadays find all these tasks in a normal storage plants or any other storage facilities of different e-commerce also. So these tasks are very simple tasks. So let us again compare these three modes of your prime movers using this simple task that is just shown in the right side of your screen. So the task considered is how to lift a load by a distance of 500 mm. Okay, so again, if you go for an electrical system, what are your possibilities? First one is your solenoid. I think most of you all are aware of solenoid. It is nothing but an electromagnet where you have a central core, okay, and then you have your wires wound around that cores. Okay, so whenever you energize those wire, then again that core behaves like a magnet, and it can again pull something that is ferromagnetic in nature. Okay, and if you just release, then that again entire core gets de-energized or demagnetized, and again you can just leave that thing. So one way of doing the task can be of a solenoid. Again, solenoid is an electrical system. The second way of doing is that I would not go for the third category, because the second and the third are both same, either with a DC motor or an AC motor. Again, since you all have gone through different types of motors in this, again, so again both you can do it with either a DC or a AC motors. So what are the limitation of a solenoid? Since the travel movement of the solenoid, okay, is very less. Okay, so again, what would happen? The distance, okay, up to which it can pull a load is limited by the movement of the inner core within the solenoid. So typically it is around 100 mm. So what was the distance of the load that it has to be lifted? It was 500 mm. So of course what we will do is that we will be ruling out the solenoid. But wherever again you have your applications where these load are to be lifted up to a very small height, okay, say that falls within the limit of a solenoid, then again you can easily do that using a solenoid. The second options are your motors. So you have your electric motors, but again I told you, since the load has to be lifted, so what would happen? The first where is the first limitation of an electric motor? Since it is a rotary device, you have to convert that motion into a linear motion. Okay, so here as an example, if you can see in the figure, you can do that using a screw jack of arrangement. Okay, so where the rotary motion of the motors is getting converted to a linear motion, and then you are able to lift the weight. Again, here you will not have any limitation of the height up to which you can lift, because you can use your screw jack arrangement accordingly to the height that is getting lifted. Fine. What would be a second limitation of this electrical systems? Your stall of the motors. Okay. So when the weight has lifted up to its designated height of 500 millimeters, okay, the motor has to stop, right? So that again, what would happen? The travel limits has to be detected here. So if you can see in this picture, you have your top limit switch and then you have your down limit switch. Okay. So again, these two limit switches would be there to detect the lowest end position. Okay, whether the load is at a lowest end position, and when it has again reached the topmost position of 500 mm, then again there should be a limit switch to detect. Only then it can say the motor to stop or stall. Okay, so again you will be requiring some auxiliary equipments comprising of, here if you see, are two limit switches, and then there also has to be a motor overload protection. Suppose your this entire task or entire this arrangement gets stuck somewhere, then what would happen? The motor has to be protected against the overload, because the motors are trying to run and lift the load, and when it is stuck somewhere, it has to be a overload protection to protect the motor against it. So again, these type of auxiliary components will be required in an electrical system if you are trying to do the same task using an electrical system. Okay, if you talk about the load limitation, again there will be no load limitation technically if you use a motors, because you can again increase the horsepower rating of the motors if the load is very heavy, and then again you can have your particular selection of your gearbox ratio of your screw jack mechanism, so that your again you can lift the motor up to a certain height, and also a certain amount of weight can be lifted. So all those arrangements can be easily done by selecting the right capacity of the motors. So this was one method of doing the task. Okay. Now there is another method, and that would be a hydraulic system, right? So again, even in the hydraulic system, a hydraulic linear actuator can be suitable for this task. The linear actuator you can see on the right side, okay, in the figure. So again, what it does, what it consists of, a linear actuator, it just consists of a movable piston that is connected directly to the output shaft. For example, you have your output shaft here, okay, so on top of which your load will be kept, right? And then there is a piston here, and this is a piston rod that is again having a connection to this weight. So what is going to happen is that whenever you will be pumping the fluid through pipe A, then what would be happening? This thing would raise up to that limit, okay, and then whenever you want to retract the cylinder, that is if you want to bring this load down, then what would be, you would be pumping the pressurized liquid through pipe B, and then again your shaft will retract, bringing the load to its lower end position. Okay, so again the maximum force available from the cylinder would depend upon what? Your fluid pressure, okay, and second, your cross sectional area of the piston, because F is equals to again P into A, right? So it would be your force is basically a product of pressure into area. So one would be your pressure, and the second would be the cross sectional area of the piston. So if you have a higher load that is to be lifted, again you can increase the fluid pressure, okay, similarly, or you can increase the piston area to lift that. So if you just want to have a typical idea of what a hydraulic basically pressure, say I have a 150 bar of hydraulic pressure, so it can lift 150 kg of weight per centimeter square of the piston area. So say if your weight was a 2000 kg weight, so you can say you can just achieve that by just a 4.2 centimeter diameter piston. Okay, so having a just such a small cylinder, you can lift up to a weight of 2000 kg. So again, it gives you a very high advantage of your power to weight ratio of the hydraulic cylinders, okay, the actuators that you are going to use. So what are the systems, okay, or what are the components that make up your hydraulic system? So if you see here, uh, there is again a reservoir, fine, the blue color that is here. You have your filter, okay, then from those filter this liquid is actually pumped. So this is a pump, and what drives the pump? The electric motor is there that drives the pump, okay, and then you have your pressurized fluid that is coming out through this output here, okay, then there is a pressure regulator here that regulates the pressure, and then here you have your control valve. What does that valve do? It actually directs the fluid motion, okay. If it the pressurized fluid, if it is directed through this path, then again this leads to the extension of the cylinder, finally lifting the weight. And again if you just put the valve, okay, to the opposite side, to the lower end position, then of course your pressurized fluid is directed towards this port, okay, and then you retract the cylinder back. Now again during the extension, when the fluid is entering this port, the fluid has to retract also, the fluid has to drain out from the other port, okay, because you have also fluid in this area. So the fluid will get drained out, and again it comes and gets to the reservoir. Similarly, during the return stroke, your pressurized line would be connected to this port, that is this port here, while your drain line would be connected to your reservoir. Okay, so basically there will be two ports. From one you will be entering the pressurized fluid, and the other would be your drain fluid. Then you will again can extend the cylinder and the lower the cylinder. Fine. If you just look at the what are the different components and what are the different features, okay. So again the system would be requiring a liquid to operate, since this is a hydraulic system, okay, and the piping acts as a closed loop. I told you in the previous. So this will again act as a closed loop system, that is with the fluid transferred from the storage tank to one side of the piston and again returned from the other side of the piston to the tank. So what does this sentence mean? That again if you have to extend the cylinder, you will be putting the pressurized fluid here, okay, and then again the other the fluid that is present, that was other present in the this side, that would has to be get drained from here and get and connected to the reservoir again back to this place. So again this has to work in a closed loop system. Second, how would you do a speed control here? So speed control would be done by regulating the volume flow rate, okay. So if you want to have a higher speed through which you are going to lift this work, then again the volume flow rate supplied to the cylinder would have to get increased, okay, and then if you have to slow it down, then again you will be decreasing the flow rate of the volume to the cylinders. See, the travel limits, you don't have to worry about the travel limits here, as opposed to that of the electrical systems. Why? Because the cylinder's stroke length of the cylinder would again determine your travel limit. Suppose in this case there was a stroke length of 50 centimeter. Suppose I had to leave the same load to a distance of, say, suppose 1 meters. Then again what I have to do? I have to change the stroke length of the cylinders. That is the distance between the lower end and the upper end of this cylinder. Okay, so this length would change. Then again my the distance up to which this weight is getting lifted, that would change. Second, again end of travels or no travel protection is required. Okay, so but again as it was there in the electrical circuit, where you had to apply a overload protection to the motors. Okay, similarly if there is any by any means, if suppose this arrangement gets stuck, okay, so when your cylinder was extending, it only extended up to say 50% or 60% of the limit, and it got stuck, then what would be there? Your motor, electric motor, would start, actually it is running the pump, and your pump would keep on building the pressure, okay, not knowing that the cylinder is stuck. So what would happen? You also have a pressure regulation here, okay. So where you set, if my pressure exceeds beyond a certain limit, say 150 bar or 200 bars, okay, then again that extra pressure would again get diverted, and that fluid would return back to the reservoir without any further pressure being applied to this system here. Fine. So if you just again just recapture or just recapitulate the key features of an hydraulic system, I would say there would be a pump. Why you require a pump? Because again that pump would be driven by an external source, that is the electric motor, to build the pressure in the system. Then again you require a filter so that the fluid needs to be clean, so that it does not choke the system. Okay, and then since it is a oil based system, then again there are some problems related to leakages, and that would be there, and in some cases it would be or it would prove to be a hazardous situation, okay, if there is a leak of pressurized oil. And again, because of extremely high pressures that we work in, okay, in the hydraulic system, a major failure can be catastrophic. Okay, so these things you should bear in mind, okay, while you work on the hydraulic system. So while you have your pros, okay, for the system, there are some cons also to the systems, okay, and then that you should keep in mind. Next, suppose we were to use the same task, okay, using a pneumatic system. What would be there? The basic actuator design, okay, that is your cylinder, would remain the same, okay. Although, what would happen to the design of the cylinders? Okay, the design of the cylinders would be changed a bit, because if you see a hydraulic system, it generally works into a higher pressure, for example 150 bar, 200 bars, 250, 300, but whereas your pneumatic system, since it works on gas which is compressible, it generally works on the tentative range of around, suppose 5 bar to 10 bars. So again, your pistons or your cylinder that is there, your basic actuators designed for a hydraulic system would again contain or would be different in constructions, okay, the component size and your strength of the component, but the basic for example your components, that is your piston rod and your cylinder motions, they would again be the same. Okay, the materials may change, okay, and different sealings and all the tubings, they would be again changed for a hydraulic system and your pneumatic systems. In this case also, the force, okay, that you can apply at this end would again depend upon your pressure, okay, pneumatic pressure, as well as your cross sectional area of the piston. However, I said you, the operating pressures of the pneumatic system is much lower than that of a hydraulic system. So we generally work in a typical range of 5 to 10 bars. So just I want to give you a just if you just compare it to a pneumatic system. So if you are working on a 10 bar of pressure, okay, then it will be able to lift a weight of 10 kg, okay, per centimeter square of the piston area. So see, if you had to lift a similar 2000 kgs of load, then what would be the piston diameter here? It would be 16 centimeter, right? And in the case of a hydraulic system, if you just recall, what was it? It was just 4.2 centimeters. So you see, for a same amount of load to be lifted, okay, using a pneumatic system, you require a very large piston, because you know 16 centimeter diameter piston is a very big. So again, that same task can be done using a smaller actuators if you are going to work on a hydraulic system, but for a pneumatic, it would be requiring a larger actuators. Why? Because your pressure, okay, at which your pneumatic systems work is very much less as that to your hydraulic pressures. So again, the rest of the part, okay, for example, all your control elements that is there to just extend the cylinders and to retract the cylinders, they would again be the same as that of your hydraulic systems, okay. So what would be different? Your actuators would be different, and the second, what would be different? Your power generation. I told you there is a generation part, there is a control system, and there is a transmission systems, okay. So again, the power generation, okay, that is generating the entire pneumatic pressures and all those would be different, but the valves, that is the control section, okay, required for the your upward and your downward movement and all those things, your flow rate control and all those things would remain the same in case of a hydraulic and in case of a pneumatic systems, okay. However, if you have to see, one notable difference would be arise where In your hydraulic system, there was a closed loop system where again the oil from one side when it was pumped, from the other side it has to be drained back to the reservoir. In your pneumatic system, what is the reservoir? Your atmospheric air. So your atmosphere itself is a reservoir, right? So what you do, you just apply a pressurized line, your drain would be to your atmosphere itself. Okay, so it is simply vented into your atmosphere. You don't have to have a closed system for it, right? So now if you see the components of a pneumatic system, okay, so you see here you have a compressor. Okay, this compressor is actually run by an electric motor there. In that case, what if you compare it to a hydraulic system, what was there? What was generating the pressure? An electric motor was running a pump. Okay, and where was the fluid? What was the reservoir there? A tank having a storage of oil. Okay, so a reservoir in the form of a tank was there. So where those oil was first pumped to the first was just sucked to the pump. The pump was being run by a electric motor, and then the pressurized system was being fed to your hydraulic actuators. Okay, in this case, what is there? Since your reservoir is your atmosphere, there has to be a system, okay, in between where you can store the compressed unit. So your electric motor runs the compressor, and your pressurized gas is actually stored in the compressor here, receiver tank. Okay, from there onwards you have your air conditioning unit where you have your, it is normally called as your FRL unit, where you have your filter, your pressure regulator, as well as your lubricator. Okay, this valve, if you see here, this is a manually controlled valve. Valve was also required in case of your hydraulic circuit also. And then finally this is a cylinder. So again, if you just pump the pressurized or your compressed air through this unit, then the cylinder would extend. And if you have to retract the cylinder, then what you would do, you would be putting the pressurized air from this port, and it would retract the cylinder. So if you just talk about your basic again components, fine. So again, air is drawn from the atmosphere, okay, by all these air filters, and then again it will have a compressor where, and then it will have a storage area here, if you see, and from the storage area you have your control elements, right? And then before going to the actuators. Okay, even in this, if you see, what is this line that shows here, this part, same here. Suppose this cylinder gets stuck, okay, and your pressure starts building on this line, then what would happen? There has to be some mechanism to divert the extra pressure. So suppose this compressor is again running, and your reservoir is getting full. Okay, once it is full, this, what is this? There is a pressure sensor here that sense, okay, now your required amount of 10 bar of pressure has been above. The next what it would do, this would actually tell the motors to shut down. This would again shut down the electric motor here, and no more pressure would be building up. Similarly, if the cylinder is stopped here due to some reason, it gets stuck, then again you have your pressure release valve in between your transmission lines also, that would sense that, and it would release the valve. Similar, and another one notable feature, if you can see here, is your exhaust. Okay, that you see here, it is a open loop system again, where your all your return air that is there, it goes back to the atmosphere. Okay, you do not need to pump it again back to the reservoir here. Fine, again, these are the basic systems or the components that is required for a pneumatic systems. Now let us have a comparison between your all these three types of prime movers if you just apply. So you have your electrical, you have your hydraulic, as well as you have your pneumatic system. So if you talk about the energy source, in the electrical portion, what is it? It is usually supplied from outside. Okay, when we talk about outside, what I'm saying, because generally you get your electricity from your outside source. Okay, so there is a electricity where your electricity is getting generated, and then you have a transmission line and your supplier, or your distribution channel from where the electricity is distributed. From there, your energy source actually runs into your motors, and it drives your motors. In the hydraulic system, what has happened? Either you have an electric motor that drives your pump, or your pump can also be driven by a diesel genset. Okay. Similarly, your pneumatic system, there will be a electric motor to drive the compressor, or again you may use a diesel generator, okay, to drive the electric motor, which in turns just compresses the gas. If you talk about the energy storage, if you have to run an electrical system, okay, so then you will have to use your batteries, and those batteries are limited. Okay, it can run for a limited period of time, right? For a hydraulic, again it is limited, okay, and for a pneumatic, it is a very good source of energy. Why? Because suppose I have a bigger compressor, bigger size compressor. I store all the compressed gas here, okay, once, and then I take the system to a place remotely located where you do not have any electricity or there. There also I can work my pneumatic systems, okay, because you have an entire reservoir of compressed gas that is there. So generally you have a good energy storage in case of a pneumatic system. Now let us talk about the distribution system. Okay, in case of an electrical system, the distribution is excellent with minimal loss. Okay, because you have your electric wires that is actually taking your supplying the energy to different motors everywhere. In case of a hydraulic, it is generally limited. Okay, basically it is a local facility because you cannot have such high pressure lines, okay, running through your entire shop floors or your factory floors. In a pneumatic, if you compare to an electrical hydraulic, it is in between, it is good. It can be treated to a plant-wide service. For example, if you can say you have a central compressor source, and from there onwards again all your pressurized gas is run through pipes, and from their pipes you can take on different outlets can be taken to run different your components. Okay. If you talk about the energy cost, again, although the initial investment cost in an electrical system is very high and precise, but to run a system, okay, electrical system, you require the lowest energy cost. Okay, then it is medium as if you compare it to your hydraulic, and pneumatic it is the highest. Okay, then if you talk about the rotary actuators, in electricals, of course, you can have one of the best rotary actuators in case of your DC motors and your AC motors, which have pretty good control over themselves. In case of a hydraulic system, those actuators are having good control, but again the speed would be slow. Okay, but in case of a pneumatic, your speed can be high because again because of the compressed gas, when the gas expands and passes through your rotary actuators, it rotates it pretty fast. Okay, so basically you have a wide speed range, and if you can just control the pressure, you can also control the speed. Okay, or if you can control the flow rate to the rotary actuator, you can also control the speed. But then accuracy, if you control, if you talk about the accuracy by which you can control the speed, that is very less in case of a pneumatic as compared to your hydraulic. And of course in electrical you can have a very accurate speed control. Fine. In case of a linear actuators, uh, if you are using a solenoid, then again those it would be a very short motion. Okay, but if you are using again your motors, DC or AC motors, via any mechanical conversion for a rotary to linear, then again there is no limit for that. You can have a linear actuators. Even in case of your hydraulic, you can have your linear actuators. Your cylinders are linear actuators. They can again apply very high amount of force. And for pneumatic, again you can have your linear actuators with a medium force. If you talk about the controllable force, it is again for electrical, it is possible for all. For in case of solenoid also it is possible, and for motors also. In solenoid, how will you control? You can control it by the amount of current that you are supplying. Okay, so accordingly your magnetization or your field is controlled, and hence your magnetization of the inner core is depending upon the current that you are supplying to it. Right? Hydraulic also it is controllable, but again the forces are higher, and in case of your pneumatic it is still controllable but with a medium force. Some points are to note, points are to be noted for these three types of systems. For electrical, again you have dangers from your electric shock. Nowadays almost all your foolproof systems are there. and your hydraulic, you have your leakages and your different fire hazards, because if there are oil spillage, okay, and then it can lead to your fire hazard. In case of pneumatics, the systems are generally noisy because of your compressed gas. When it expands over the systems, and all your exhaust relief valves and all, they all make the noise of the systems. So these are some of the points that is to be made. Finally, if you can just have a quick review of all the components, okay, that is used in a fluid power systems, be it your pneumatic or your hydraulic, your some basic equipment. So you will be having a tank or a reservoir. Okay, so in case of a pneumatic, those reservoir would again be your compressed gas. Okay, and in case of your hydraulic, it would just be a normal tank holding the fluid, because the pressure or the pressed liquid is only obtained after that liquid passes through your pump. Okay, so again a pump would be required to force the liquid through the systems. Electric motors will be required in both the case, one to drive the pump and the other to drive the compressor. Okay, then there the valves will be required, which will be actually controlling the direction of the fluid, okay, to the either end of the cylinders. Okay, then you are going to have an actuators. Okay, those actuators can be your linear actuators or your uh, rotary actuators, and then you will also be having your different piping arrangements to connect these different types of elements, right from generation to your transmission to your all your control elements. They all has to be connected, so your piping will also be there to carry the fluid. Okay, so then comes your fluid power actuators. Okay, so you are going to have your linear actuators, both hydraulic and your pneumatic, and then your rotary actuators, both your hydraulic and pneumatic. So what you can see at the left hand side of your screen is a schematic representation of a linear actuators, and again in the middle you have your symbolic representation of a linear actuators, and towards the right you can see as your rotary actuators. Okay, in our course that we are doing here, we will be focusing all the application that we will be focusing, we will be dealing it with the linear actuators. So in this course I'll be focusing more on the linear actuators part of it. Okay, so I have with me some linear actuators that I'll be showing it to you. So let us just go to it. Fine. So what you can see here, okay, is your single acting cylinder. When I talk about single acting cylinder, what is it? Generally what you have seen in the examples that is there, that there are two ports to the cylinder. Okay, so when I have to extend the cylinder, I put a pressure line here and I drain it from this side, other ports. Okay, so that is known as a double acting cylinder. What you see here is a single acting cylinder. Okay, in this case, what is there? To extend the cylinder, you put a pressurized line here, and the retraction, if you can see, is through the spring mechanism. Okay, just see here. Suppose if I have to extend, what I will do, I will put a pressurized line here and this cylinder would extend, right? So if I have to retract the cylinder, what would I do? I would just leave. I do not need to pump my fluid from the other port, because the other port is absent here. Okay, so what I will just leave, and the cylinder returns back through the spring mechanism here. Okay, if you can see. Now just have a look at a double acting cylinder. Okay, so see, what you can see here is a double acting cylinder. So you have your two ports. Okay, so again, if I have to extend the cylinder, what would I do? I would have to put my pressurized line to this port. Okay, so that the fluid will enter through this. Okay, and for this cylinder to extend, what would happen? You also have to drain, because since if you can see the piston moving here, this is the piston. Okay, the circular thing, if that piston is moving, what would happen? The fluid from this side has to get drained. So what would happen? The fluid would come and drain from this port, right? So whenever I have to extend, what will I do? I will put my pressurized line here, the cylinder would extend. Okay, and the extension is only possible if there is a drain unit here also. Okay, similarly, if I have to retract, what would I do? Through the valve, now what I would do, I would change the direction of my pressurized line. Earlier my pressurized line would suppose going to this, and this was my drain line. Through the valve that is there in certain sitting somewhere here through the control element, what I would do now, I would change the direction of the pressurized line to this. Okay, and again my fluid will flow right here. You can see this is a transparent arrangement. So fluid will flow through this and put the piston back to the this side. And in the simultaneously, what would happen? Your liquid would get drained from this side, and it would retract back. Okay, so this is known as a double acting cylinder. Okay, both of them, and what I showed you earlier, this is known as a single acting. Okay, why? Because to extend this, you have only one port. Okay, when it is extending, what would happen? Again, the same case here. There must be a port here. Okay, that actually releases the exhaust gas. Okay, because see, to extend this again, this has to release the gas that is present on this side of the portion. And again, when it is retracting back, this will act as a drain port, because the spring is acting as a force to retract it back. And at that time, when it is retracting, the air has to, or your pressurized fluid has to, unpressurized fluids have to flow from this line. Okay, so this is one. Now let me just show you a cross sectional view. Okay, see, just let me have another component here. Okay, in this it will be much more clear. Okay, so if you see this is again, what is it? It is a single acting cylinder. Okay, so again, for the single acting cylinder to extend, you must be having a port. So since this is a sectional view, you can say, or a cut section. Okay, so you can see this is a cut, this is a port here, it is cut here. So generally fluid enters from here, okay, goes to this through here, and then it pushes this piston, it applies pressure on the piston, and this moves forward. Okay, now see, when this is moving forward, there has to be a exhaust port to return. So if you see in this diagram, I hope you can see, this is a exhaust port. Okay, that means the air is just this is a pneumatic cylinder. Okay, so you can see the air would again just press from this side and release from here. And to release it, what I have to do? I don't have to apply any pressure from this side, because this is again spring return. So through this spring action, it will return, and when it is returning, my again liquid, my compressed air, or in this case this would not be compressed air, this would just be a uncompressed air, would again flow back through the line. So if you see, you here, this is called a piston rod in between. Okay, then again you have a piston here, you have a piston here, and all those valves, if you can see, these are the O-rings to again just prevent the air from flowing from this is the cylinder element, if you can see like this. Okay, to these two ends of the cylinders. Okay, and in between you have this. Now let us see another example of your double acting cylinder. Okay, so let us see again the same way. This is a double acting cylinders. So you have your two ports here, again all cut. One is the port here, the other port is here, right? So when you will put a pressurized line here, the cylinder would extend, and during extension, see, this is not spring mechanism, so it will stop in the between also where you are going, and then this would extend, and while extending, the air would drain out from here. Okay, now to retract this, what I have to do? I have to put pressurized line here, so that the air will flow into this and push the piston back. Okay, and during its backward motion, air is getting drained out from here. Okay, and if you see here in a double acting cylinder, you do not have any springs in between. Why? Because the return mechanism is also a return through your pressurized line. Okay, while in the case of a single acting cylinder, you have a pressurized line to extend the cylinder. Okay, to retract, you do not have. Retraction is only through the spring force. Okay, so this is more for a simple arrangement. Again, when we will do some pneumaticals or some problems, okay, then we will see where we are going to use a single acting cylinders. Okay, what valves are required to control a single acting cylinder, what type of valves are required to control a double acting cylinder, because see, to control a single acting cylinder, if you see, you have only one port through which your pressurized liquid has to go, isn't it? Whereas in the case of a double acting cylinders, you have two ports. So with this, I would be again stopping my lecture. Thank you so much.